In this activity, we're going to look at how many colleges are you applying to, and we're going to be looking at the mean and standard deviation. All right, so before I get started, just to recap some of the notes here, I highlighted some pieces. For example, you can ignore Chebyshev's theorem. That's a pretty cool thing, though. So make sure here's your formula for standard deviation that we'll be using today, and then you'll never use it again. Okay, we don't use that formula really. And if we scroll through, trying to see if there's anything we've got here on this page of the notes, it talks you how to put the data in Statlet, and you've already been doing that, and it'll calculate standard deviation right there for you. And that's pretty much the main point of this lesson. Oh, and actually one other thing. This page right here, page 12, we don't really have this in the activity, but we do cover it for our quiz, so, which you'll have not next class, but class, well, anyways, which you'll have either the next class or class after that, depending on the year. Anyways, so one of the things we find when doing all this is that standard deviation measures of spread don't change if we add a constant, okay? But everything else changes like you expect. So if you're adding or subtracting a constant, there's no change on spread. Why is that? Well, it's because your dot plot, I think I have one back here. Let's see. No, I don't have it. But basically, if I do a dot plot of the data, here we go. No. If I looked at this data and did dot plots, I would see that it's just shifted. So the min and the max change by the same amount. So for example, let's look at the range. In this example, if they have the lowest is 185 and the highest is 245, the range is 60. If everyone loses 5 pounds, then you have 180 to 240, and that range is still 60. So because it's a measure of spread, it doesn't tend to change when you just add or subtract. But when you say you change it into a different unit and you're multiplying, then those values will change. So if you want to get a preview on that for the quiz when we have it, make sure you go through these notes, okay? All right, now how many colleges are you applying to? So this is from a previous class set of data. And you can see I had 6 tables in this class. And I had them report the number of college applications they were doing. And we need to do the mean and the median. So for the median, I went ahead and listed them in ascending order. We're initially working with this data by hand. And so I know it's halfway between 8 and 17, so the median is 12.5. The mean, we just add them all up and divide by how many there are. So we did that last lesson. Now we're going to do something called deviation. So standard deviation is a form of measuring the distance from the mean. So what do we start with? We start with the actual deviation or distance from the mean. So we said the mean here, once I divided it, was 13.3. So let me go ahead and highlight that for you right there. So there's that 13.3. Actually, let me choose a different color. We'll do purple. So there's 13.3, and you can see it's there and there. I didn't write it again there because it was the same point. And then what you do is you get this difference, right? And you square it. So this one right here, let me just go ahead and fill in that data. 8.3 squared, so if I square it, get a squared, there we go, that's 68.89. If I take 5.3 squared, and actually put it in parentheses, because if you don't, your little calculator is going to say, what? Let's see, equals 2. So that's how we're getting the numbers over here. So we take every single data point. You don't have to list them in order. It doesn't matter. And then we square it, subtract it to find the distance between that data point and the mean, and then we square it. So why do we do that? Well, if you actually added all these values, negative 8.3, negative 8.3, negative 5.3, you'll actually get 0. So it's not taking the straight distance from the mean is not very helpful because the average distance is always 0. So we have to, well, the average, because it includes negative going backwards and positive going forwards. I think in middle school, you actually learn a variation where you do absolute values. But it's more mathematically convenient. It's actually easier if we just square all our values. So we square all our values, and then we're basically going to take, and we add them all up, and this is called the variance, all right? I'm sorry. We add them all up, and that's the sum of the squared variations. Then we divide by how many data points we have, which is 6. And we get 58.223, and that's your variance. The only problem with using this to measure spread is we know that the average distance between these data points at 13.33 is not 58. They're not even, the range isn't even 58. 58 is too big a number. So the reason that is because we squared it. So then what we're going to do is we're going to take a square root of it, and that gives us our standard deviation. So sigma is the standard deviation of a population, also aka SD, all right? And so we take the square root of that, and we get 7.63. So that makes more sense. If you look at these, you can see a 7 kind of popping out, right? It's almost like looking at the absolute value of these, and that makes sense. Now, if you go to Staplet, let me go ahead and enter the data. What do we got? Let me just copy this data for a second. We'll go to Staplet. So in the future, we don't do this. This is one single group of data, and it's quantitative. Put it in there. Begin analysis. Oh, and we can say college apps if we want. I like having labels. Begin analysis. And you can see there's a dot plot. And here you can see that the standard deviation is 8.359. Is that the same as what we had? No, we had 7. So what's going on? Well, when you have a sample, you're not getting all of the data. So you're not measuring all the spread. The probability you're going to have the maximum value and the lowest value to give you a true feel of spread is not super high, okay? So they make an adjustment. They kind of bump this value up, and they say, how are we going to do that? Well, we'll just divide by a slightly smaller number. Instead of dividing by n, we divide by n minus 1. So luckily for you, that's the one we tend to use in all our calculations, and the Staplet does it automatically. All right. We forgot to add one group that applied to 40 colleges. So let's go do that. Let's add a group in that did 40 colleges. Yes, that's fine. Begin analysis. So now what happened to my standard deviation? So there's my mean. There we go. That's all I really need. Copy. There we go. So here's our new value. Control C. Let me try that again. Trying to get that. Copy. This should work. Control V. There we go. That's what I was looking for. So the mean went up. That makes sense, right? Because we have more. Mean went up because we added 40 to the total, right? Before dividing by 7, all right? And then the SD went up because variance went up. Basically, the distances, let's just say that. And spread is higher. That's intuitively obvious. Intuitively, it's like, hopefully it's like, yeah, definitely the spread's higher. You added this point that's way off, right? So that is what's going on. All right, so now calculate the mean annual rainfall for these cities. So if you put this data in your statlet, let me see, I'm going to steal this off to the side for a second. And I'll show you how to put the data in the statlet. This is rainfall. And here's the data points. 8.2, 10.3, 33.5, 39. All right. And I guess this is in inches, I think. That's okay. Yes. Inches. Begin analysis. And there's your dot plot, which probably, if I do a histogram, looks a lot like the one in your exercise. All right. And you can see there are the values right there. So if I go ahead and copy this, summary stats. Yeah, never ever, I tell my AP kiddos, never ever copy, never ever calculate standard deviation by hand, all right? There's no reason to do it. So let me go ahead and paste in my statlet data here. So I just pretty much copied everything. And also you see we got the median here, right? So there's the mean, there's the median. And we would use the median because the data skewed left. We learned that last lesson, all right? And this is how we interpret. Luckily for you, not a big deal. For my AP stats, you need to be able to interpret things. And so you would say the annual rainfall for a city typically varies by 15.52 inches from the mean of 34.94 inches.